Hello everyone, I am Liam Lawson, and for my Physics 302 honors contract, I'm going to be walking you guys through solutions to 3 problems. In this problem, we are going to be deriving a recursion relation on the Hermite polynomials. Now, as a minor note, the Hermite polynomials are usually written in terms of chi, but my chi's look like squiggles, so we're just going to write in terms of x. So, for this problem, we are allowed to start with the two recursion relations. Hn prime of x is equal to 2n times hn minus 1 of x, and h double prime n plus n, h double prime n of x minus 2x h prime n of x plus 2n hn of x is equal to 0. And what we're trying to derive is hn plus 1 of x is equal to 2x hn of x minus 2n hn minus 1 of x. So essentially we're trying to derive a recursion relation without derivatives involved, which makes it a little bit easier to work with the polynomial since derivatives kind of take a little bit of time. So, first step, since our biggest index here is n plus 1 and our biggest index out of all of these is just n, we're going to start by turning this first equation in terms of n plus 1. So we have hn plus 1 prime of x equals 2n plus 1 hn of x. Now this only gives us an n plus 1 and an n. So if we want an n minus 1, we're going to want an h prime of n. So we'll take the derivative of this. So we get h double prime n plus 1 of x is equal to 2n plus 1, that's a constant term, so it stays the same, times h prime n of x, which is equal to, using our relation up here, 4n n plus 1 hn minus 1 of x. So then we take these two relations, since we have a double prime and a prime, and we plug them into this, and we remember to switch the index from n to n plus 1 at the beginning. So we have 0 is equal to hn plus 1 double prime of x minus 2x hn plus 1 prime of x plus 2n plus 1 hn of x, hn plus 1. So then we plug these in, and plugging in the first one, we get 0 is equal to 2n plus 1 hn plus 1 of x minus 2x times 2n plus 1 hn of x, which is 4x n plus 1 hn of x. And then we need to plug in hn plus 1 double prime of x, which is equal to 4n n plus 1 times hn minus 1 of x. So we're almost there. The first thing we're going to do is get rid of the 2n plus 1, since that's a common factor throughout all of these, which gives us 0 is equal to h n plus 1 of x minus 2x hn of x plus 2n hn minus 1 of x. Then we just move this over to the other side and flip it around, so we get hn plus 1 of x equals 2x hn of x minus 2n hn minus 1 of x, which is what we wanted, so we are done. Thank you for watching this video. I hope you found it informative, and make sure to check out the other two where I go over some more problems related to what you're going to be learning in this class. Thank you and goodbye.